Very good. So it's 8:34. I can start. We we have good number of audience, so we are also. It's also on YouTube. So if someone is not able to attend, they can watch this video later. At any point, if you are not able to hear me, let me know. So welcome to the session. This is like infrastructure as a code. This is a very broad topic, very broad. So I'll try to cover as much as I can. Might take few sessions. In this session, I'll cover the breadth of it, and then maybe we can have, depending on the interest, we can have other sessions. Okay, so let's start. Feel free to post your questions anytime. I'll answer them once a topic is covered or immediately, depending on where I am. This is the agenda. So I'll talk about infrastructure. First, I'll start with Agile DevOps CI/CD because it's important to know everyone is talking about infrastructure as code. Why is this? Why did this become so popular? IaC. Where did this come from? How did it suddenly become popular? To understand a little bit of history on how it came up, Agile DevOps. And then I'll give an introduction to IaC, all the tools, not all the tools that I know that are popular in the market, and what we use, how we use our framework. You might use it differently. So how you use it, and little bit details on the tools that we. That's what this will be. This session will be. Next sessions we can go deep on the hands-on and all details on the tools. Okay. So most of you, every one of you, you might be using Agile, right? It's like Agile is all about creating software that is always ready to release at any point of time. That's the main intention. Whether you are using Scrum or Safe or other frameworks, this is the reason you want to be Agile. So what does that mean? How can we at any point of time? Everyday developers will be checking a lot of code, and there are like changes happening. How do we make sure there are no bugs? We need to have a complete continuous delivery pipeline. The developer checks in, your tests should all run, and other things. So if you have performance tests, you have code scans, they should all run in a pipeline. And at the end of the pipeline, it should say like, okay, all good, go ahead, we can release this. That's how we can achieve continuous delivery or like delivery anytime, right? So that's how the CI/CD, shift left, all this became popular. Last few years, these are like the hot topics everywhere. You see CI/CD, shift left. Uh, so that's how continuous delivery came in. Um, and then with the continuous delivery, so when we are doing continuous delivery, we also need the hardware to run the test. Traditionally, how it is like there is a team, IT team or systems team, who takes care of all the hardware. They give us the hardware. They apply patches to the hardware. It's like we give it to them, they give it back. I mean, we ask for a hardware, and then they come back and say, okay, this is the hardware you need. And if you do a value stream mapping to the whole thing, there you'll see a lot of delays, lot of waste there, right? So that's how the DevOps thing came in. DevOps might be a team, might be a culture. It's like doing both. It's like combining development and operation. That's what DevOps is, right? And in the continuous delivery, when I'm talking about agile and continuous delivery, Safe has continuous delivery as part of agile framework, Safe framework. So DevOps combined development and operations. That's how DevOps became very popular, which means you build it, the team builds it, the team runs it, the team does whatever it requires to run it. Like if it means provisioning the software, installing something. So that's a little bit history on the terms that we have been hearing recently: continuous delivery, DevOps, why. So now, uh, Little bit details. This is like from Wikipedia. What does continuous delivery mean? How does it work? So this like a developer checks in a code, the Scrum team, a developer, QA, testers, they check in the code to version control. For suppose you're using Git, so you check in, you do a pull request in Git, and then it immediately triggers a build and runs your tests. So until the tests are passed, your check-in will not go through. Right? When a test fails, you have to fix it. You get the feedback. You have to fix it, and then you do that again. So that's the CI part, continuous integration part of the CI/CD, CI/CD or CV, continuous delivery, continuous deployment, continuous validation. There are different versions to the second part of it, but this is the basic of the continuous integration. So, for example, now you have a good CI system in place. What if the check-in is all good and your tests failed because of other reasons? What can be the other reasons? It might be like the test is flaky is one. So assume you have taken care of it. You have a rock solid test, and that should be the primary thing when you're doing CI or CV. The other thing that your infrastructure can be flaky. So when can that happen? I take my examples, some of our examples. So we use third-party softwares like databases in our application for our applications. We need some of the third-party databases. What we used to do is we used to have a hardware there with the database, and it used to run continuously. And whenever a test run, it uses that database. Over time, what used to happen is with databases are heavy, right? The hardware might be choking somewhere. It took all the CPU memory, or the database table space is full, and so it cannot run. It runs out of memory, out of disk. So all those issues used to come in once in a time, and when that happen, it blocks my check-in. And when this check-in, someone is waiting, like a customer, it creates a lot of frustration, right? So that cannot happen. Even without third-party databases, like when you're using a VM or a hardware, they keep patching those hardware, so things will go wrong. If there is a drift that will happen as you apply patches again and again, as you install your applications again and again. So that's where the concept of mutable and immutable infrastructure came in. This is also the terms that we are hearing a lot recently. Mutable infrastructure. That's what we need to use. What does that mean? Mutable is what we used to do traditionally, like using the same servers again and again, and then patching them. Would require reboot once in a week, once in a month, or schedule once quarterly, and it's all manual process. Somewhere it can lead to errors. We never know. It's all manual. A IT guy, a DevOps guy, a systems guy enters in. He applies some patches, or weekend something happens. The network is all gone bad and it all disconnects. Anything can happen. So immutable is all done through code. Whenever you need it, you bring in a machine. It's all through code configuration files. You bring in the machine, you configure what you need, you use it, and then you destroy the machine. That way, it's also a lot of. It's like they're not idle. The mutable part of the world, if I'm using database only for 1 hour, 2 hours a day, it's still that system is running, and we don't let people to use that system, others to use it because we're afraid that it might corrupt my database, happen something, and my test fail. So there's a lot of waste there, the efficiency factor. That's all like the advantages of immutable infrastructure. And that's how IaC was born, like a combination of agile, continuous delivery, DevOps, and immutable infrastructure. How can we make our CD pipeline more and more stable? How can we make it robust so that it will only fail when there is issue with check-in, not because of the hardware issues, or other things. So I covered most of it. What is IaC? But a little more details. IaC is like previously it's all we have seen it. Like we have been in the most of you here. We have been in this industry long enough. We have seen physical servers being configured and kept for use, and then software and patches being repeatedly installed on this machine. And somewhere the drift happens, and we say like, okay, my my check-in is not working. My check-in is all good, but it's not working. So something is wrong. Some patch lost, some version of Java, something, and it's a manual process, so prone to errors. So infrastructure as code is like managing your data centers through configuration files, just like your software. These files reside in your source control, whether it's Git or other things. It GitHub or other things. It resides there, and we don't have to depend on anyone. We develop the code, we provision the software, we provision the infrastructure, we configure the software, and we run our things, our tests. It's all done. It's all like one place. This is a quote from Martin Fowler, like long back, not now, many years back. He said, "A server should be like a phoenix, regularly rising from ashes." Phoenix is like a Greek mythology, ancient Greek mythology. Phoenix is like a bird that rises from dead or ashes. Server should be that way. You cannot have like a server sitting there forever. This is to avoid the configuration drift and all. That's how the IaC came in. So clear, right? Any questions? Why we are talking about all this terminology? How did this become popular? Agile, DevOps, CD, CI, shift left, continuous delivery, continuous validation, IaC, mutable. These are all the buzzwords. If you go to any conference, QA, DevOps, these are the buzzwords. So now to the tools part. What are all the tools? There are like several tools in the market last 5 years, 8 years. There are like several tools that came in. These are the tools that I know of that um, I have tried a little bit or I know of kind of. There are many other tools, and these are also some of the popular tools. Packer, Terraform. These are generic tools from HashiCorp. These both are Packer, Terraform, Vagrant, Vault. These are all from HashiCorp. Uh, these are all generic tools. They are open source. Works with multiple vendors, either VMware, AWS, Azure, Docker. They they have a long list of vendors that they can work in. So you can provision any kind of infrastructure using Packer and Terraform. And CloudFormation is specific for AWS and Azure Resource Manager for Microsoft Azure. Um, so like if your company, if you say like cloud, I am only using AWS infrastructure. I don't have in your company any other hardware for testing purpose. So you can directly go. I think you can go with CloudFormation because when they're tied to a specific vendor, they provide some more additional capabilities, right? That's what they do. They're tied to a vendor. But if you have like a need, like my development is on VMware, vCloud, and my deployment is on cloud, AWS, Azure, and I might be using some other things like Docker, Vagrant. So the Packer and Terraform are a perfect. Packer is more of a server templating tool. I'll talk about it. Uh, Terraform mode of provisioning tool. So that's the provisioning part of it. Um, like their combinations. Okay, I'll complete the other one. And then once you provision your hardware, you have to configure your software there, right? Like in your company, you want Java to be installed throughout. So you require Java for your application. Um, what is the difference between Terraform and Packer? I will get to little details, Prakash, in a bit. I'll go little deep into Packer and Terraform. If I don't answer your question, I'll get back to your thing. There, Packer is like creating images at a high level. It's like a templating tool. You can create identical images using Packer. Terraform is more of a provisioning. When you create identical images, if you have an image, you can create multiple images using Terraform. That's how we use it, but many people combine these tools together. They use Packer for provisioning, for plus configuration management, um, server templating plus provisioning, provisioning plus configuration. They use mix of these tools to achieve the whole IaC purpose, which I'll talk about. If I don't answer it, ping me again. I will get into details. Um, so configuration management tools, these are like some of the popular tools out there. Ansible, SaltStack, Puppet, Chef. Ansible is kind of recent means last 4 years, 5 years, I think. Puppet, Chef, SaltStack, they came before Ansible. And Ansible is more popular. If you see the GitHub downloads or other thing, Ansible is more popular now. There are various reasons. Chef, Puppet, SaltStack, they all require you to install agent software on the machines on each server that you want to configure. Ansible does not require an agent. It works through SSH. So that's one major advantage of Ansible. Uh, these are the configuration management tools. So when you have the hardware, you can configure with one of the configuration management tools. You can say I have like shell scripts for that. Why do I need it? That's how we traditionally used to do. My company has hundreds and hundreds of scripts, but it's like using JavaScript versus jQuery or React. What the advantage? They have a lot of things automated for you, and they make sure that they can give you a state which is like not a drift from the actual state. Always they give you the same state. You don't have to do a lot of things to get a Java installed or do something. They have provisioners or they have like modules that can do that for you with just one line that can happen. There are a lot of advantages why you use configuration management tools instead of traditional shell scripts or some scripting language to achieve this. Um, and then there are like containerization tools like Docker and Vagrant. Vagrant gives you a portable development environment. It sits on top of your laptop or VMs, so it gives you a development environment that you can work on. It's on top of the existing hardware. That's what it is. And Docker is it's like a container technology that provides platform. So you can use containers also for your development. If you want like complete platform as a service, use Docker. Or like if you want like a Linux machine on top of your Windows, and then if you want to share that machine across to your other team members, you can use Vagrant. And when you're using all this, it involves a lot of teams. It involves a lot of tools like TeamCity for all this CI to manage your CI CD. And when you're using all these tools, you need passwords to create machines or install something. So and you cannot have those passwords uploaded everywhere. That's when you can use some secret management tool like Vault again from HashiCorp. That's part of that's what we are using as part of our IaC stack. There might be other tools. So when you say IaC, this is the whole stack. There might be parts of it that you might use. Only one of it Terraform to achieve everything. Can you? Yes, you can achieve, but is it the right way? It depends. It depends on your requirement. What are you trying to achieve? Is it simple? Is it complex? Do you have different teams that are using this IaC, or is it one small team that is doing it? It depends on things, but they are developed for a specific purpose. But slowly they move to other things also. A provisioning tool can do some amount of configuration. A configuration tool some amount of provisioning. Same as like Shell script can do anything. I can use the APIs to create a machine. All the VMware provides me APIs. I can install things, but why? Like, there are advantages of using them. So a little bit on the framework. This is the framework that we use. It's not like it doesn't fit your needs. It's proprietary. This is what I have designed in my company. So at the bottom you have the infrastructure, whether it's AWS or the VMware infrastructure, whatever it is, and then you have templates on top of it. A image out of VMware, you need a VMware template. If you want a AWS instance, you need an AMI there, and on top of that, Packer provides builders. We create builders through which I can create spin a machine with the builders. I'll talk about this a bit. How does the builders look? How do they work? Once I have the builders, I can do a little bit of configuration provisioning also, or like I'll use Ansible or other things to provision. And then there is Ansible to provision things. I need Oracle, I need Java on the machine that I have spin up. So I'll do Ansible. Now I have an image with all the requirements that I need for my application to run. Now I use Terraform to create multiple images. These are now identical images, exactly same what I need, because I used code to do it. I know I created a clean image and did my code to do it. So there's very little that can go wrong here. So the tools have a lot of things to make sure that they don't go wrong. For example, the Ansible talks about idempotent state, which means if something is in a state that you want it to be, it doesn't do anything. It just comes out and say you have everything required. For example, if you're doing a start server, if the server is started, it doesn't do anything. To do that in a shell script, you need to do a lot of coding again, right? If else if. So Terraform, you use it to get identical machines, and then you can run your tests and destroys everything at the end. And Vault for secret management. Redis is an in-memory database to feed the test to the Terraform. That's what we are using. This is our entire framework for IaC. You can have only Packer and Ansible. You can have Terraform and Ansible. There are combinations that you can use when you're using IaC. And this has different parts, right? We say like we work together, we create packet builders, but we say IT wants this. This has They own the infrastructure. Even if we develop and it's part of our Git, they own it. And going forward, if there is a new builder that we need, they can create it along with development. But they own this part, and playbooks are owned by mostly development, little bit of systems team in our thing, um, depending on what kind of playbooks we have. If there are common playbooks that can apply for the whole organization, maybe systems team can. This is like Terraform is again engineering, and Vault is like IT central, so secret management. So we also have clear distinction of who owns what, how they are used. Um, there are a lot of things like at the high level. These are the things that we have. So little bit into tools, not very deep. They're not very complex tools. If you go through them, and they have amazing documentation. Each of these Packer, Ansible, Terraform. If you go through, they have examples. They have documentation. If you go into GitHub, there are hundreds of examples. Hundreds, not hundreds, thousands of examples. You can look at the code, how each way how they did it. So Packer, as I said, is like used for creating identical machine images. So this is the only thing that Packer can do. It can do a little bit of provisioning, but main part it's like creating identical images from the VMware template, from the AWS AMI. You can create any image and then it just shuts down that image and it provisions the image and shuts. Sorry, it creates a machine, provisions the machine, and creates an image of it. And then, if you want, we can upload. That's the life cycle of the packer. And it supports, as I said, multiple providers. So you can use Docker and Vagrant for development, AWS for production, and it's all through template files. Um, it, you write all the packer um, things in a JSON file. So example of how it looks. Packer says calls it the builders. When you want to create a machine, you write the builder. What kind of machine do you want? I need a vSphere machine. These are the details, username, passwords. I'll use a separate variable files to pass them all, or I can pass it through command line and other details on like what is the CPU, RAM that you need. And Packer communicates with remote hosts using a connection framework called Communicator. So that's like SSH. It supports SSH and WinRM for Windows. So this is how the builder looks, and it turns a template into an image. And you can have multiple builders. I can create one vSphere, one AWS image in one Packer file. A little bit. So if you um, go into the Packer website, they will list all the builders that they support. These are all the builders, and it with an example. Like how do I do it for DigitalOcean? It gives you what are all the required things, they're optional things, and it gives you basic examples. This is how you provide your builder for all things, whatever you want, Vagrant, VMware, everything, AWS, like Amazon EC2. How do I do it? It has all the details. You can go through them, um, and it lists you all the builders. And as I said, variables, you can pass it as a separate thing or as a command line. Right? Once you build it, you can also provision it. Like I have the base image now, it's like a bare metal, but my company uses Java across. It needs Java across for running my application, or it needs a database, it needs some Redis server. So you can configure basic things and you can create an image. So everyone has this image instead of a bare metal. So that's what provisioners are for. And you mentioned what you need. And it has like a lot of provisioners available, nearly 1,000 provisioners. So you don't have to write anything. You have the provisioners available. You say like I'm using a Ansible provisioner to push my Ansible playbook I'll talk about and runs installs, or I want to use a shell provisioner and install. I use a Linux command to install Redis server. So that's what provisioner is for. So whatever you need for across the organization, you should do it here. And again, some individual needs, like in your organization, you might have 10 different teams. Each team's requirements are different. Then bare metal, it's good to do it as a bare metal and do what you need. At least what we do is like we provide bare metal and what the whole organization needs. And then each team, if they need more, they configure other software through Ansible separately once they have the bare metal. But sometimes you might say like this saves a lot of time. This looks very good. I have a machine created and I have the software, required software also, and I will give that image to everyone. That saves me like 10-15 minutes. Directly I bring that image up. I have the required software. I also have my application maybe, and then people can start using it directly. So 15 minutes, it saves me 15 minutes. It's all about speed, right? When you have the CI/CD pipeline. So it depends on your requirement, how many provisioners. It can be like I only want to give an image, or I want a small provisioner. I mean, I want to have like a few provisioners available. And when you feed this to Terraform, it creates identical image with similar software, all the same version. It cannot miss that because Terraform maintains its state files. It knows what exactly is there. Ansible makes sure it's idempotent, the state is idempotent. So it's like there are so many checks done to make sure it's all good. So that's what the provisioning part does. And then you generate the image and you can upload the image to. Once you generate the image, there are post processors. So these are optional things. You can compress it and upload the image to a file place where it's accessible to everyone, or you can create a variable box. That's post provisioning step. So that's all Packer does. Uh, so now I have, oh sorry, yeah. So these are the three steps that I have. Once I create my Packer file, JSON file, I should Packer validate. If there are any issues, it gives me. It's like compiling my Packer file. And then I can directly say like Packer build my file. Or I can pass the variables here, and or like I can pass a variable file. I can pass many number of variable files. Um, and then it creates the these are the commands to use. Okay, so now I'm up to this part. A little bit of this, I did some configuration. I have an image built. I have like maybe Java installed there, and now Teams are ready. Teams can take this image directly and say like, okay, give me an image. I have Java installed, but I also need Oracle or like other things there. So for that, that's where Ansible, the configuration management tools come in. That's what Ansible is. It's an IT automation tool to configure your systems. You again, you can say I have scripts for this, but there are several advantages of using a configuration management tool. Many things are automated for you there. Only requirement is Python for Ansible to run. There are no other requirements. Most of the Linux machines they come with Python, so basically you don't need to install anything for Ansible if you are running on Linux. It's agentless. That's one of the main advantages. It uses SSH to push the required things. And idempotency is an important Ansible feature. It prevents unnecessary change in the managed host. So you can execute one or more tasks on a server as many times as you need, but it won't change anything that's already been modified. So that's what it is. That's very important thing. That's what they market a lot. Um, just to say, put it simple, the only changes added are the only ones needed and not already in the place. They requires a lot of coding to do that. This is how it works. The server has the playbooks and the inventory of all the hosts where you need to push. And in your playbook, you write it. Okay, these are the hosts. I need to push this software, this configuration into this host, some other configuration into different hosts, and you can. That's Ansible into little more details. So Ansible is written in YAML. YAML is so like I want to show you some files, complete files. How does it look? I forgot to show you. So I talked about Packer files, right? This is how it looks. I can have variables at the top, or it can be a separate file. I'll have my builder there, with like what kind of machine I want. I'm like trying to create an image, and then I say like I want Ansible and like run create a Redis server. So this is my complete file. You don't have to remember a lot of things. There are a lot of examples in the documentation I showed you. Like if you want to look at variables, builders, provisioners, I think provisioners. So yeah, I'll show you later. Um, it has a lot of examples. So this is my Ansible file. You can just copy paste to start with, and then try to add to it. If it's AWS, it's much more simple. I recently did it. Right now, I don't have an Amazon account to show you. I have a GitHub project to create an Amazon instance there. Simple. This is like simple builder, and I pass my access key and secret key through command line. Um, Ansible file. I'll talk about it. It's an YAML file. This is how my playbook look. Ansible calls it playbook. Playbook has plays. So my play is like uh, to make sure Apache is latest. Apache is up to, I mean, make sure Apache is latest, and Apache is running, start Apache. That's my playbook. Those are the two tasks in my playbook. And these are called modules. I'll talk about modules in Ansible. And I say like run this playbook on all the hosts, on all the servers that are defined under web servers in my host file. Um, So it once I run it, it runs this file and installs Apache latest. Make sure it's Apache. Make sure it's the latest, and then it starts Apache. Right. So in order to happen, we need to. Ansible has modules which are standalone scripts. Sorry, there are hundreds of modules available. If you want to write a module, your own module, you can write it using Python. But so far we didn't have any requirement to write our own modules. Whatever we need, they're all available. So you can directly use those modules and say like, for writing, doing a installation, from installing something, running something, moving files, all those are already there. So if you uh, haven't heard about YAML, YAML is a full form YAML ain't markup language, or some people say yet another markup. YAML ain't markup language is the right thing, I think. It's a human readable data serialization standard. That's all. It's a superset of JSON. Uh, Similar to JSON, I feel it's easier to read than JSON. JSON is for file exchange, but it's like a YAML is different. So you can read through YAML. It's simple as JSON. So playbook is like a text file written in YAML. It contains one or more plays, a task or play, I call it. Uh, it will run in this order. What else do I need to here? So Ansible has these modules, different modules that you can use, hundreds of modules, as I said. So you can, if you want something database files, you can go just copy those modules, copy the syntax, use it. I want to do a copy. How do I write it? So these are all the syntax, and if I want to copy file with owner and permission, this is how the code should look. Uh, Different ways of copying. So it has all the things you needed. You just copy them, use them. So that's the beauty of using these tools. Uh, yeah, we talked about packer builders, Ansible, and the inventory files. If you want to understand how to use Ansible inventory files, host files, it gives you a list of how to write them, how to group them, how to use it. It's all there. Okay, uh, playbooks, modules. Now we are here. I have my machine. I have all the things that I want configured. I'm ready. I have the perfect image. Now I want to run my tests. Some people directly, I have seen in my company also, directly running the tests in Packer when they are doing the provisioning. They also run tests right way, but they say like I have 5 tests in my CA, I can complete it in the Packer part in the provisioners. They do that, but when they want to distribute, they use Terraform. Now I can distribute. I have a machine with exactly similar things. I can distribute my thing. Uh, Sorry, I have machine here with several things, exactly the same things, and I will distribute and I can run my Ansible, or I have Ansible run as part of this. I'll distribute them. That's where Terraform comes in. We use Terraform for creating identical images. You give it a base image, feed it a base image, it creates an instance of it and creates identical images. It's like again building and provisioning. It can also provision after that. It creates identical images and it can configure provision software on top of it. That's what Terraform is for. Um, so this is the basic life cycle of a Terraform. I do a Terraform in it. It is in it. What it does is it goes to the provider section. At the top is the provider. Again, Terraform has a lot of providers. So like for all the different vendors. If I go here to Terraform and say what are all the providers, you can see a big list of providers that it have. You can go into any provider and you can look into. I'm using VMware vCloud or VMware vSphere. How do I use it? It provides all the details there. So with the if I once I give the provider, it's like identifies your provider and downloads anything that's necessary, all packages, plugins. Okay, and then I say I want 10 the resource part. I want 10 identical images. The name should be something like this. That's my requirement. And this is my CPU memory requirements and other details. And it exactly creates 10 images with this exact configuration that you give. Um, Now, next time you say I want 15 images. It knows it already has 10 and it creates 5. It maintains a state file. It knows exactly what it have. Um, but before that, so once you have the provider and resource, if you run Terraform plan, it provides details on like what it exactly trying to do. So it says like, okay, I have all the things required for my provider. I don't have something required here. I need something to be installed. So, or I will, in order to create an image, I need something. It fails or it says like I have this. I will exactly follow this order to do it. It tells you it requires everything that it's need or and step by step how it will do it. And once you think it's all good, you say the Terraform apply and it will create those images. That's the basic flow of Terraform. It has a state file that it maintains. That state file is used to create the plan. Again, if you go here, it gives you all the details. Again, Terraform has provisioners. Once you do same as Packer, it has hundreds of provisioners, built-in provisioners. So if you want to do some configuration here, I say I will use only Terraform or Terraform for plus Ansible. You can do. There is like you have to play with these tools to understand what exactly you want to do with them, how exactly you want to use them. Do you need one of them, all of them? And it's same thing. It gives you like a different provisioners that you can directly use. Um, that's all I have. Back to the framework. So once I run them, it all destroys it. It's your responsibility to destroy it. So Terraform the machines, or else they just lie there. Um, Packer, it just starts it and it destroys. It creates the image and destroys. It only saves the image. That's the whole IaC. They're all integrated with our TeamCity, continuous integration, continuous deployment. So how we use it for our CI servers, some teams say that they only use Packer and do complete it. But for CD thing, continuous validation, delivery, deployment, we use this stack, this whole framework for IaC. Um, that's all I have. So any questions now to any other details? I can do details on like hands-on. I think I showed you the files. They're like how the Terraform files look like. Um, yeah, there are different examples. You can Google and you can find a lot of examples on each of them. So depending on like what you want to see here, what you want to hear next, I can do demo of each of it, how it creates. I have to use AWS. I need to, I mean, uh, enable my account again. I disable my account since I'm not using it. So any other questions here, I can answer. 10 more minutes. Any questions on the whole IaC, how to use it, yeah, on the tools. So I hope I explained difference between Packer and Terraform. It's like very confusing initially when I started. Oh, why is Packer? Ansible can do it. Why am I using Packer? Terraform can do the Packer part, but Terraform is like it needs an image. So I can directly give it and it's have an image ready, and Terraform can work on it, or I can use Packer to create the image and the basic things needed and feed it to Terraform. How you want to use in your team? That's how um, that's that's your requirement drives everything that you need. Um, hope I covered anything. Any other questions that you have? Any more details that you want to hear? I can do a detailed demo next time to clean up some things and do it if I want to do it on cloud. Yeah, yeah. Thanks, Mani. You can play through it and you can talk to me if you have any questions. If you need more sessions, we can talk in the group on what exactly you want to hear, details. For a few days, there'll be confusion between the tools. Why, what this, why that. But when you start using, you'll understand the advantage and say, oh yeah, yes, this is why I need Ansible. This is why I need Packer combinations. So I'll use only Terraform and Ansible. I don't need Packer. So if you play it for a few days, you will understand the details on what exactly you need for your needs. Okay. I'll wait for a minute. If there are no questions, we can end this session. Okay, thank you. You can ask me questions later also. Either I am very clear or everything went above the heads. So thank you all. This is like my first live use team. Thanks to Kaya for introducing me to this, and thanks to everyone for listening to. I will definitely plan for the demo. Smriti. I have to prepare a few things, clean up. I didn't get time to do that. That's why and it's a, like a vast topic. So I thought I'll start here and then depending on the interest, I can do the demo. But definitely I can do the demo. I have a GitHub project which I need to clean up and do some things to make it demo ready. That I will do that. Okay. Thanks. Thank you, everyone. Hope you learned something today. I'm ending this session. Have a good day, guys.